Welcome you all for the today's session, problems on design of shaft. Objective of the today's session. After this session, you will be able to design solid shafts on the basis of strength, torsional rigidity, and you can design solid shaft by using SME code. Now let us start. Before starting or solving some problems, once again, I would like to recap the SME code for shaft design. According to SME code, what you have to do while taking the value of tau permissible or permissible shear stress, what you have to do if material properties SYT, SUTs are given, if it's not given, even though you can refer the data book and you can take it. So what you have to do, you have to find out the permissible shear stress according to SME code. How it is calculated? So first of all, what we have to do, we have to find out the tau max is equal to 0.30 SYT. That means 30%. 0.30 means 30% of the SYT. And tau max 0.18 SUT means 18% of the SUT. Out of these two, whichever is minimum, that you can use in our calculation. Then sometimes in problem statement may be written gear is keyed to the shaft by using key, maybe statement like this, or sometimes neglect the effect of keyway also. As per the your the problem statement, you can take into consideration the effect of keyway. If keyway is present, you have to reduce out of these two, whichever is minimum, further by 25%. That means you can multiply it by 0.75. That means you have to take into consideration only 75% value of whichever is minimum. Remember, if QA is present, and if it's asked, no need to consider the effect of QA. That time don't reduce by 25%. Then don't multiply by 0.75. Remember this thing. Directly whichever is minimum, you can use it. This is one thing. Second thing, again here, all these the design aspects yesterday we have discussed based on the static load condition, but in reality what is happening, very well, in actual practice machines or machine elements are subjected to shock and fatigue. This is because of the cyclic load or a dynamic load or change in magnitude of load during its operation. How to take the care of this shock and fatigue? That's why, according to this SME code here, shock and fatigue factors are introduced, and these shock and fatigue factors are multiplied to bending moment MB and torsional moment MT. So that's why two factors are introduced. One is KB. And what is KB? KB is the shock and fatigue factor for bending moment. So you should multiply KB to the bending moment only. Look at this here. KB should be multiplied to MB. Similarly, KT is the shock and fatigue factor for torsional moment. And you have to multiply by KT to the twisting moment or a torsional moment, that is MT. Remember this. And you know very well, according to maximum shear stress theory, tau max. Tau max means, suppose if you are going to use a SME code, whichever is minimum, you can use this is the tau max. If QA is present, further reduced by 25%, you can use this as a tau max. Remember this thing. And multiply this MB by KB and MT by KT. And according to maximum normal stress theory, sigma is equal to 16 pi d cube in bracket KB MB plus under root KB into MB square plus KT into MT square, bracket complete. This equation here also you have to multiply by KB, you have to multiply by KT to MT and KB to MB. Remember this thing. Okay, and yesterday we have seen how to take the value of KB and KT. For that purpose, sometimes in problem statement it may be mentioned load suddenly applied or heavy shock. sometimes minor shock, sometimes load gradually applied. Remember these things. According to this application, you can take the value of kV. If load gradually applied, kV is equal to 1.5, kT is equal to 1. If load is suddenly applied minor shock, kV is equal to, you can assume 1.5 or 2. It's your choice. It is in the range of 1.5 to 20. But what is kT? kT in the range of 1 to 1.5. Similarly, when load suddenly applied, you can take the value of kV in the between 2 and 3 and kT in between 1.5 to 30. So you can take 2, 2.5. It's your choice, no problem. That's why you have to refer the chart. This is about the SME code of shaft design. Remember these things. I hope you got it, because based on that we are going to solve the problem. Now you can take your notebook and pen with you and you can note down this. It's a general problem I have taken. You can note down. I am going to read the problem statement. You should always read problem statement carefully. Look at this here. Pulley drive is transmitting power to a pinion. There is a pulley which transmits power to a pinion, which is turn transmitting power to some other machines. That means through this gear pair, it is power is transmitted to some machine or some machine element may run. Pulley and pinion diameters are 400 mm and 200. Pulley diameter 400, pinion diameter 200 mm respectively. Shaft has to be designed for minor to heavy shock. So you can consider heavy shock condition for kV and kT while selecting the value of shock and fatigue factor for bending and shock and fatigue factor for torsional moment. Remember this thing. Okay. Now figure is given. You can refer. I have shown here in this figure. This is bearing B. This is bearing A, where it gives support to the shaft. This is the shaft where pulley is mounted. Look at this. From bearing A or left hand side bearing, pulley A is located at a distance of how much? 200 mm. Then on the same shaft, gear is mounted, but here it said pinion. We can say it's a pinion gear. And always, you know, the pinion means small gear. It is located from the pulley at a distance of 400 mm. And then again bearing B, from which this gear is mounted at a distance of 200 mm. Remember this thing. Second, in side view, I have shown here side view of this. This is the pulley. Look at this outer diameter. Look at the cursor. This is the pulley diameter. Outer diameter of the pulley is given. How much? 400 in problem statement is given. And for this gear or a pinion, what is the diameter? 200. For a gear diameter means it's a PCD, pitch circle diameter of the gear. Remember this, 200. And distance between the bearing A and the pulley 200, bearing B and the gear 200, and distance between gear or a pinion and the pulley, that is 400. Again here one thing is shown. Look at this, the pulley. W is 1000 Newton. What does it mean? It's a weight of the pulley. It is the weight of the pulley, and because of that, you know very well, weight always act towards vertically downward direction. The weight is also shown. Then again here in side view you will find pulley transmits power to the pinion, and pinion then transmits powers to run some machine. But here for the pulley you will find always, you know, this is the pulley. How it is transmits the power? This is the belt, you know, the belt drive, or is in this way. Okay, here I have shown it's a horizontally transmits. Look at the figure. This is the outer diameter of the pulley, that is 400 mm, and here it is shown the two forces, 1000 and the 4000. So you know very well in theory of machine, you might have studied in applied mechanics. Belt drive consists of two forces and is having two sides. One is tight side, another one is the slack side. So you can consider here these two forces are, this is tight side tension T1 and slack side tension T2. Remember, Therefore, T1 is equal to 4000, T2 is equal to 1000. Because for a belt drive, two forces, tight side tension and slack side tension. This 4000 is a tight side tension, and always tight side tension is maximum tension. This is the slack side tension T2. You can use the nomenclature. I hope you got it. Then gear, this gear, look at this gear. Gear diameter is given how much? 200 mm. PCD. You can say this is the gear, P circle diameter of the gear, 200 mm. But here on this gear, you will find here some forces are shown here. In a horizontal plane, 20 to 100, and in vertical plane, actually it is the plane in 6000 Newton. How it transmits the power? Again here gear, the PT, tangential force, is the useful force used to transmit motion, power, torque in gear drive. You know very well. Now what is the, once from a power, if you have a torque, from a torque, PCD into this force, PCD by 2 into force, you will get the torque transmitted by the gear. For a pinion, you can say tangential force Ft. If I am going to write for a mt of the pinion is equal to, which force is important? Ft, tangential force. Ft into dp. dp is the pitch circle diameter of the pinion by 2. F into r is equal to torque force. Remember this thing. And similarly for a pulley, what is the torque? T1 minus T2 into radius of the pulley. What you will get? You will get the torque, because T1 and T2 is also force into this radius. The F into R is nothing but a moment, that is torque. Remember these things. This formula we have to use it. I hope you got it. So you have a force tight side tension. You have a force slack side tension. Here for a pinion, in this it's not mentioned which type of pinion, but two forces are given. That's why it's a spur, because radial force and tangential force is also given in this case, radial and tangential. Now let us start what you have to do. Once you have understood the problem statement thoroughly by observing the figure or the given all the data, what is next step that you have to follow? You have to always write the given data. You can note down now. You have pen and pencil with you. You can note down pulley weight is given 1000 Newton in figure. Then tangential force transmitted by the pinion is given PT 6000 Newton. Radial force 2200 Newton. Then tight side tension. Always the tight side tension is the maximum tension in the belt. Remember this thing. Okay. This is T1 and T2 is the slack side tension. Then pulley and pinion diameters are given. Pulley diameter is 400 mm and pinion diameter, that is PCD, 200 mm. Now let us find out twisting moment MT or torque or a torsional moment. How to find out? You have two options. How? Because pulley and gear or a pinion, which is, or you can say pulley and gear or a pinion mounted on the one shaft. That means whatever may be the torque transmitted by the belt and whatever may be the torque transmitted by the gear remains same. Therefore, you can take into consideration maybe belt or maybe gear. Look at this for a belt. How to find out the MT? As I have mentioned, MT is equal to T1 minus T2. You can note down T1 minus T2 into R. R means radius of the pulley. The pulley diameter 200. You can substitute. What is T1? 4000 minus T2 1000 into what is R? Radius. Now you can multiply it by 200. because pulley diameter 400 therefore. And what you will get here? You will get 600 into 10 raised to 3 Newton mm. Then next, even though you can calculate by using the gear also, how gear is going to transmit the torque. So you know very well, torque transmitted by this pinion here, mt is equal to tangential force ft into dp by 2. What is dp? Dp means pitch circle diameter of the pinion by 2. Or you simply you can say it the radius of the pinion, and this is the ft tangential force. So what is ft is given 600 dp by 2, again 200 mmPCD. So you can divide by 200. You will get mt is equal to this. You can use this or this, no problem. Remember this thing. Now you have mt because while designing the problem, we should know the mt and mb. And then we are going to use the formulas based on maximum shear stress theory under root, you know, the mt square plus mb square is equal to this relation. That's why it is very important to first calculate mt and mb. Because of this motion power transmission, you will get the twisting moment and you can determine in this way. Now I have a value of mt, no need to bother about mt. Now let us find out the mb. mb means bending moment. But how the bending moment you will get here? How you will get the bending moment? I will explain one. Okay. Now here the bending moment here you will find on the shaft, pulley and pinion which are mounted, and because of that there may be possibility of bending of the shaft, mounting of the parts. Again here in problem statement you will find in figure weight of the pulley is also given, that is 1000 Newton. But for a gear here, it is located at position D. Weight of the gear is not given, so no need to consider. Remember this thing, but weight of the pulley is given, that's why you can consider. Now let us solve two next step. First step, what we have done? We have calculated the torsional moment. Now our target is find out the bending moment. And how to find out this bending moment? So what we have to do? We have to construct vertical load diagram and horizontal load diagram, because some forces in a pulley, if you going to repair a figure, so you will find it transmits, you know, the T1 and T tight side and slack side tension in a horizontal plane. So you will get these forces in a horizontal plane. But weight of the pulley which acts vertically downward, you will get that weight in a vertical plane. Again here in gear ft, tangential force is shown in figure in vertical plane and the radial force in horizontal plane. And again what you have to do? You have to find out the bending moment at A, B, C, D in vertical loading and bending moment in horizontal load diagram at A, B, C, D, and where we will get the maximum bending moment that we are going to use in our calculation to determine the shaft diameter. Remember these things. Where we will get the maximum bending moment. This is our task now that we have to find out. Let us start. First, what you have to do? First, draw vertical load diagram. So what you have to do? This is A, this is B, and what is the distance from bearing A to C? That is 200. C is the pulley, you know very well. Then C and D, what is the distance? 400 mm. D is the pinion, it's a pinion. And then here, this is the bearing B. Now, at in vertical load diagram, reaction at A, RAV, reaction at B, RBV, and in vertical loading at pulley, remember, give attention here. In vertical loading, I have shown only one load. Which load? This is 1000 Newton. This is weight of the pulley. But what's about the horizontal load? Because it's a, I have considered vertical plane. That's why no need to consider this forces T1 and T2 in vertical loading. We will consider it in horizontal load diagram. We will consider it in horizontal load diagram. Remember this thing. Similarly, at point D, you will find in figure this tangential force 6,000 Newton. It's in vertical plane. It's in vertical plane. That's why it is shown in vertically upward. Okay, once you have constructed this diagram and shown the forces in vertical plane, the next step what you have to do, you can take moment at any one of the point. I am going to take the moment at point A. So what you will get? RBV into this distance. How much? 400 plus this 400. I have written RBV into this distance. Then minus, it's a downward direction, minus 1000 into 200. I have written minus 1000 into 200. And then this 600 up to this distance. Sorry, 6,000. 6,000 into 400 plus 600 is equal to 0. Or you can do RBV into this distance plus 6,000 into this distance minus 1,000 into this distance is equal to 0. Taking moment at A. And here, if you are going to solve, you will get RBV, reaction at point B. VV means in vertical loading. RBV you will get here minus 4250 Newton. And once you have this RBV magnitude, what you have to do? You have to take the summation of the forces. How you are going to find out this RAV? So just you have to RAV plus RBV plus this is equal to this. You can solve, putting the value of RBV, you will get RAV. And you can find out RAV. Remember these things. You know very well in SOM you might have done this. Then next, important point, what we have to do? RBV is the reaction at the point B and RBV in vertical loading. That's why V is the suffix. For horizontal loading, I am going to use RAH, RBH like this. Now, what we have to do? We have to find out the bending moment at point C and bending moment at point D. Because you will find RBV at this, you will get the bending moment 0 at point B. So let us find the bending moment at point C. How you are going to find out at C? Look at this, bending moment at point C in vertical loading MCB is equal to this 6,000 into this distance 400 minus, again here what? This. Now instead it's not a minus, it's a plus, but RBV into this distance, that is 600. But here you have got RBV is equal to minus 250. That's why directly minus 250 I have taken here. You can substitute. You will get MCV is equal to minus. Minus sign means you have to change the direction of this, the reaction. Okay, you will get MCV minus 1.5 into 10 raised to 5. No need to bother about this minus sign. Then similarly, you can find the MDV, the bending moment in vertical loading at point. So simply you can do RBV into this distance. I have done it. What is RBV? Minus 4250 into 200. You will get this. Even though to find out the bending moment at C, you can say RAV into this distance, you will get bending moment at C. This is also the correct approach. This is the fundamental of strength of machine element. You can apply. So you will get MCV, you will get MDV, these values. And remember, you can say equation 1 and equation 2 because we have to add this bending moment at C in vertical loading, bending moment at D in vertical loading with the horizontal to find out the resultant bending moment at point C and D. Now, let us find out the bending moment in horizontal loading. That's why what we have to do, we have to construct horizontal load diagram. Horizontal load diagram. How to construct? Again here, this is the point A, but remember this suffix I have used RAH at point A. Similarly, reaction at point B, at bearing position B, it's RBH. Now here at this point C, in horizontal loading, you will observe for a pulley I have shown the here the tight side tension, what is the force 4,000 and here slack side 1,000 in horizontal loading. Now it's a horizontal loading. or a horizontal load diagram. So at point C, which force is going to act? This horizontal 4000 and this. So you can add T1 plus T2 is the force in horizontal loading. And T1 kitna hai? 4000 plus 1000. That's why I have shown 5000 here. The total T in horizontal load diagram, T1 plus T2, that's why it is shown 5000. The distance you know very well, 400 mm. Then at point D, I have shown 2200 Newton. It's a radial force of a pinion or a radial load. And you know very well, radial load always acts towards the center. Remember, and it's in horizontal plane for a pinion, which was shown in given figure. And that's why I have shown here 2200 Newton at position D. Now, once you have the forces, same logic you can apply, taking the moment at any one of the points, suppose A, then RBH into this distance, minus 2200 into this distance, minus 5000 into this distance is equal to 0. You can solve it, you will get RBH, what you will get? 2900. And find out RAH. RAH plus RBH is equal to 5000 plus 2200. And you can subtract this RBH, you will get RAH. I have not done, you can do it. Once you will get now RAH and RBH, then next time what we have to do? You have to find out the bending moment at C in horizontal loading and bending moment at C, D in horizontal loading. How to find out it? You can find out RAH into this distance. You will get the bending moment RAH into this distance. This is also correct. And bending moment at D, RBH into this distance. This is also correct. Or you can suppose find out from this side. Suppose I would like to, yes, now, if I would like to find out the C, MCH, I will do this also. RBH into this distance minus 2200 into this distance is equal to this MCH. So whatever may be the method, you can adopt and find out MDH and MCH. I have calculated here, and it's always remember, try to write the units, that is Newton, mm, MDH. Now we have a bending moment at D in horizontal loading, bending moment at C in horizontal loading, and similarly on earlier side, we have determined MDV and MCV. Remember this thing. Now what we have to do? At point C and D, we have to find out the resultant bending moment. Now let us see how to find out it. Now let us find out resultant bending moment at C, resultant bending moment at C. The resultant bending moment at C, that is MC, is equal to under root. What we have to do? MCV bracket square plus MCH bracket square. Remember these things. So what you have to do? MCV square plus MCH square. The bending moment at C in vertical loading, bending moment at C in horizontal loading, you have to take the resultant. You will get MC. So you will get this value. You can do it. And because of the square, even though it's minus, it becomes positive term. Okay. So you will get MC is equal to this. Similarly, you can find out the resultant bending moment at D. Here I have written the relation. MD is equal to MDV square plus MDH square. Remember this. The bending moment at D in vertical loading, bending moment at D in horizontal loading, you can find out the resultant. You will get this. Now, please show the last slide. For now, let us, last slide. Last means this slide. Okay. You can refer this. You should know how to find out the bending moments. For that, you should have a thorough understanding of strength of machine element and applied mechanics. You can do the practice at home. You might have solved many problems in strength of machine elements for different loadings, uniformly distributed load, point load, simply supported load. Okay, now here I have determined bending moment at C, resultant bending moment, and resultant bending moment at D. Okay, sir, please show the next slide. Next slide means it's going on. Next means earlier slide. What is the problem? I don't think. Yes. You can do it fast or just draw this diagram and you can do the calculation by taking your calculator. Okay, it's very simple one. Or you can take the snapshot of this and you can check it or cross check the calculation done by me also. No problem. Okay, I hope you got it. Now I have determined MC, resultant bending moment at C, resultant bending moment at D. Then you have to check where you will get the maximum bending moment. Because in design of shaft or anywhere in design, always we are going to consider where you will get the maximum bending moment. Out of this MC at bending moment at C and bending moment at D, you will observe at C 8.7 to 10 raised to 5 and at D 10.29. So where you will get maximum bending moment at point D. So which section is critical? Section D is critical from design point of view. Therefore, in our calculation, we are going to use bending moment at D is equal to MB. Remember, bending moment at D is equal to MB. Okay, I will show how to use it. Then this is the standard, the SME code I already discussed. Again, what we have to do? We have to use this relation now. Tau max is equal to 16 upon pi d cube into under root kb into mb bracket square plus kt into mt bracket square. But in this problem statement, I have written in problem heavy load. Load suddenly applied and it's varying from minor to heavy. And because of that, you have to assume kb, it is in the range of 2 to 3 and kt, it is in the range of 1.5 to 3. You can remember, it's given in problem statement. What? Load varies from minor to heavy shock. So by referring the chart, you can note down kb in the range of in between 2 to 3 and kt in the range of 1.5 to 3. Now note down this formula. Tau max is equal to 16 pi d cube into under root kb into mb square plus kt into mt square. Now you will get kb and kt from these two values. Okay, I hope you got it. Now let us move to find out the final answer. After writing the same formula here, now I have taken, it is from 2 to 3, I have taken 2. KT is equal to, I have taken 1.5. So you can put here KT 1.5, KB 2, and MB means that is maximum bending moment at D. Maximum bending moment at D is equal to MB now here. And what is the MT? On first slide, we have calculated torque transmitted by the belt and the gear MT. So you can take any one of the MT. The MD is equal to MB is equal to this and MT is equal to 600. So you can substitute all these value. But one interesting point, what is the tau max permissible? According to SME code 0.30 SYT, 0.18 SUT, but SYT is not given in problem, SUT is not given in this problem. If it's not given, generally because of that, what I have done, remember this thing, in SPPU problem they have to provide this data. But in general, if it's not given, I have considered shaft is made up of commercial steel, and for commercial steel shaft, you can remember and note down. For commercial steel shaft, tau max permissible. This is permissible, huh? 40 Newton per mm square. Therefore, directly I am going to use this value here, 40 Newton per mm square. And if it's not given and ask use a semi-code by giving SYT, SUT, then you can do the calculation. Tau max is equal to 0.30 SYT, 0.18 SUT, whichever is minimum that you can use here, tau permissible. Then 16 pi d cube, you know KB, you know MB, you know KT, you know MT, you know tau max, that is for commercial. This value you can substitute. So what you will get, d cube. The d cube is equal to, and finally you will get d is equal to. Okay, this is one problem you can note down within 1 to 2 minutes. Then I will switch over to learning. Okay, I have changed same thing. Only this gear is replaced by the pulley. I have replaced gear by the another pulley D, and this pulley diameter is same. Only what I have done, other dimensions, you know, for the pulley is same. Right side tension 4000 PCD of the pulley, that is 400, and slack side tension 1000. But for a pulley D, I have replaced gear by pulley D, and its diameter is 200. And pulley is keyed to the shaft, I have written. And material of the shaft is 50C4. You can note down SUT 700 and SYT 460. You have to solve this problem at home, okay, as a practice. And here pulley D transmits vertically. Look at this, vertical forces are shown. And it consists of a tight side and slack side, but I have not given these forces. For that purpose, what I have mentioned, maximum tension in the pulley D is 2200 Newton. 2200 Newton. I will give hint. You can note down this problem very fast. Again, here in this problem, weight of the pulley C is given 1000 and weight of the pulley D is given 600 Newton. हो गया note down करके? Please tell me. You will note down this problem. Please tell me. You can do it fast. Yes, sir. Okay. Snaps. You have taken snaps. Very good. That's why no need to bother. Now I will give you hint within 1 minute, and then we will switch towards the learning. For pulley C, horizontal forces are given tight side, slack side. You can find out EMT, twisting moment, T1 minus T2 into PCD or pulley radius. So you will get. But here pulley D, I have given one statement, maximum tension in pulley. Maximum tension means maximum tension in pulley is always tight side tension. Suppose for pulley C, it's a T1, is a T2. I will say tight side tension for pulley D, that is T3, and slack side tension, that is T4. Here maximum tension in pulley D is given, that is T3. How to find out T4? Because it's not given. So I hope you have a hint. Here, look at this, T1 minus T2 into, what is the radius of pulley C? 200. T1 is given 4000, T2 this. You will get MT, torque or twisting moment. And this MT is nothing but I am going to write for pulley C, because they are on the same shaft. The for pulley D, MT is equal to what? T3 minus T4 into radius of the pulley D. Radius of the pulley D. Radius of the pulley D 100. T3 is given how much? 2200. MT you will get from this equation. You can find out T4. And once you will get the T4, you can do vertical load diagram and horizontal load diagram. Okay, I hope you got it. This is some hint I have given for this problem. You can solve it at home. Thank you. I have referred to Bandari's book. Thank you. Thank you very much. You can try to solve this problem. Thank you.